this video, I'm going to go over mass to mole to atom conversions. So we will be using Avogadro's number. Okay, so I have 3 problems for us to do. So you're going to want your periodic table and your calculator. So let's start with this first one. How many atoms are in 6.79 grams of lithium bromide? So remember, as we're solving these problems, and I'm just going to move this so I can write. As we're solving these problems, we always start with given and find. Okay, so we always want to start by kind of telling ourselves, hey, this is what I'm looking for in this problem. So your given is always going to be a number. So I have 6.79 grams of lithium bromide. And I'm trying to find the atoms of the lithium bromide. Okay? So I'm going to save myself some time. I know I'm going to have to calculate the molar mass of lithium bromide, so I'm just going to do that right now. So lithium, there's 1, bromine, 1. So lithium's atomic mass is 6.94, bromine's is 79.9. So I could probably do that in my head, but I'm not going to even try. So the molar mass, when you add these guys together, is 86.84 grams per mole. Okay? So again, when you're calculating molar mass in these types of problems, units, I don't really care about them in here, but do have them on your final number, final answer. So here we go. Always, always, always start with what you're given. So I'm going to start with 6.79 grams LIBR dot and a line. So we know that we want grams to go away. So in order to have our grams go away, it needs to be on the bottom. And this is because you got 1 on the top, 1 on the bottom, goodbye. Okay? When we're going from grams to atoms, we have to go through the mole. We can't just say, I don't feel like going through the mole today, so I'm just going to ignore it. That's not how it works. We have to go through the mole. And I'm trying to find my flow chart. Aha. Okay, so we're going from grams. We have to go through the mole to get to atoms. Okay? So that means my unit up here will be moles of the LIBR. Okay? So this is where I'm going to fill some info in. And again, I'm using these conversion factors, and I'll show you this here. So when we have grams and moles, we're plugging this in. So we're going to have 1 mole over the molar mass. So 1 mole over 86.84. So if we stop here, we're in the unit of moles. We want to get to atoms. So we have to add a dot and a line. Okay? So this is the new step. We want to end in atoms. We want our final unit up here to be atoms of LIBR. That means, okay, so these guys go away because one's on the top and one's on the bottom. So we want moles to also go away. So that means I have to put moles down here. Mole LIBR. And again, 1 on the top, 1 on the bottom, goodbye. So we will be left with atoms. Now we just need to plug in some numbers. So again, looking at our conversion factors. That's not our conversion. Here we go. We're going to use one of these. Okay, so for the example we have moles on the bottom, atoms on the top. So we're going to use this one. Remember, the number 1 always goes with mole for right now. 1. And every single time, no matter what, when you're solving for atoms, 6.022 times 10 to the 23rd always goes with atoms when it's in your equation. Okay, so this is set up like this. Okay, now we're ready to calculate it, and I'm going to show you what I'm typing into my calculator. How I do this, pretend this is over an imaginary 1. okay? I don't write it because I know it's on the top because of how I set it up, but if you need that imaginary one, put it in there. Everything on the top gets multiplied. Everything on the bottom gets multiplied. Divide those two numbers. So this is what I'm going to type into my calculator. 6.79 times 6.022 times 10 to the 23rd equals that number. Now, I would, if these were not ones on the bottom, have to multiply. But it's 1 times 86.84. So I know that it's just 86.84. So now I'm going to hit divide, parentheses, 86.84, close parentheses. Enter. Now my answer is in scientific notation. So I need to have two decimal places, so 4.708, that rounds to 1. So 4.71 times 10, remember this E stands for times 10, and then 22nd. That's my number. Now I need my units, which is atoms, LIBR. So that's one problem, going from grams to atoms. Let's do the opposite. Let's go from atoms to grams. So again, start with your given and find. Always start with given and find. Your given is always the number. In this case, it's 4.13 times 10 to the 26 atoms of magnesium oxide, and we're trying to find the grams of MgO, okay? This is a compound. I'm going to calculate molar mass. So let's do that down here. 24.31, 16. Add those up. There's one of each. And we get 40.31 grams per mole. So now I'm ready to go. I'm ready to set this up. I'm always going to start with what I'm given. So I'm going to rewrite my 4.13 times 10 to the 26 atoms MgO. Yes, you need to write the unit and the compound. Okay? So we're working backwards this time. We're trying to go from atoms to grams, but we have to go through the mole. Okay? So looking at the flow chart, we're going from atoms through the mole to grams. So that means we're going to start with one of these conversion factors. Oh, my pen. So we have atoms on the top here. So that means I need atoms on the bottom to get them to cancel out. So I'm going to use this conversion factor. Remember, when you're in a conversion factor, Avogadro's number always goes with atoms. So it's going to be 6.022 times 10 to the 23rd atoms of MgO. And over that will be 1 mole MgO. So if we ended here, we would be in the unit of moles. We want to be in grams. So what do? Dot and a line. So now that we're at the mole, we need to finish with one more step to get to grams. So we're going to use either this conversion factor or this one. So moles on top here. So we want it on the bottom here. So we're going to use this conversion factor. So we're going to have the molar mass of our MgO over 1 mole MgO. So the molar mass is 40.31 grams MgO for every 1 mole of MgO. So as you see, atoms on top, atoms on bottom. Mole on top, mole on bottom, left with grams. Here we go. Here's the math. Everything on the top gets multiplied. Everything on the bottom gets multiplied. Then we divide. So, parentheses, 4.13, second, comma, to get that E, 26. Close parentheses. New parentheses, 40.31, close parentheses. Enter. you get this number, which is in scientific notation. That's perfectly okay. We're going to hit divide, parentheses, and then we're going to type in Avogadro's number. Close our parentheses, enter. And we get, for an answer, 27,645.35 grams MgO. Round to 2 decimals and you're all set. I have one more. Okay, so we've done grams to atoms, atoms to grams, but let's do atoms to moles. Okay, so it's still considered an atom conversion, but it's not as many steps. And I messed this up. What am I doing? I'm having a moment. Okay. So this one, we're going to start with our given and our find. We are given 3.27 times 10 to the 24th atoms of HCl. And we're trying to find our moles of HCl. Okay. So again, HCl, H 1.01, Cl 35.45. So we get 36.46 grams per mole as our molar mass. So I'm going to start with what I'm given. So I'm going to rewrite my 3.27 times 10 to the 24th atoms HCl. Dot in a line. So I want atoms to be on the bottom because I want to get rid of it. Atoms, HCl. But if we go from atoms, we got to go through the mole. So mole, HCl, will be on the top. And that's because I'm using this conversion factor. Atoms on the bottom, moles on top. So the number 1 always goes with mole for right now, and every time 6.022 times 10 to the 23rd always goes with atoms. So we want moles, and look, we're in moles. So this is a one-stepper. So we're going to put our equal sign, and now it's time to do some math. So how we type this in? Turn your calculator on. Parentheses, 3.27, second, comma, 24, close parentheses. So we are dividing our given by Avogadro's number. I'm going to use parentheses. It's good practice to use parentheses because sometimes your calculators don't understand what you're saying. So when I hit enter, I get 5.43 moles of HCl. And that right there is how we do some mole calculations involving grams and atoms.